project we want to talk about today is actually a project that we did jointly last year, which was basically taking assets within the Marcellus Shale, placing them in a GIS. What we do want to talk about, basically a summary of the Marcellus, and we want to kind of talk about gathering systems within the Marcellus to kind of set the context for how these systems currently exist, some of the challenges they're faced with it, the specific project of Peoples Natural Gas, the unique opportunities that it actually presented, the data collection means that were established by Peoples and working in conjunction with Pulse, our field data collection, what was happening there, the challenges we had, and finally how P&G is actually using this data. But before we get started, how many of you kind of feel like the ugly stepchildren within your PI with GIS in your companies? And this has been a challenge. You're kind of the afterthought, I think is the phrase that we phrase. How many of you actually feel like that or have in the past? So most of the people do. And it's a consistent problem, and that's something that was unique about this project is we tried to shift that from where the GIS was the afterthought to where GIS was driving the buses being sent. So within the Marcellus Shale right now, there's an estimated 100,000 miles of gathering lines within the state of Pennsylvania alone. The vast majority of these are within the Marcellus Shale. And of those, only about 570 currently are being regulated by the federal government under PINZA. This means that the other 99,430 miles is essentially in a regulatory gray area. It is not regulated by the federal government. It is not really regulated by the Public Utility Commission. Most of these systems are not even under PA one call. How many of you heard of the one call system? So there's 100,000 miles of pipeline in the state of Pennsylvania that currently, or the vast majority that does not, when you put a one call request in, show up. So that's a challenge right there. This is important because right now there's 14,000 shale wells within Marcellus. They're wanting that to grow to about 120,000 by 2020. Now with current gas prices, I'm not sure if they'll hit that. But that's a really big challenge. Because every month, about 100 miles of large diameter, high pressure gathering systems are being dropped in the state to get the gas from those wells that they're drilling to sales pipelines. What do you think's in the way of those pipelines as they run from new wells to a sales pipeline? It's that 100,000 miles. A lot of this is largely unknown at any level of accuracy. The federal government, in fact, for class 1 pipelines, low-level threats, they only have to be accurate to 500 feet. That is their mapping accuracy requirement. They are pushing to go to 50 feet, and there's a lot of pushback within the pipeline industry. With limited location knowledge, leak detection, and other maintenance programs are often incomplete. If you can't walk over the gas pipeline and don't know where it is, how are you going to be able to do a leak survey? You got to be within a few feet of it. And finally, there's no condition assessment. If you don't know where your facilities or assets are, how can you go out and do a condition assessment on any portion of it? So this brings us to Peoples. Peoples, about 2 years ago, began negotiations from another firm to purchase their assets. Part of this purchase were 2 gathering systems, so a total about 371 miles of pipeline, spread over 2 counties, Washington and Greene counties, right in this neck of the woods. And these systems had a history of condition issues, including substantial, very substantial loss and unaccounted for gas ratios. And these were very, very high. Peoples knew this going in. So in early 2014, P&G actually commissioned a project to designate the lines, the gathering systems, and complete a leak survey. And we successfully completed that in 2014. This is actually a unique opportunity. When we got the original RFP from Peoples Natural Gas, the spec for the data collection device was an eTrex 20. Anybody know what the Garmin eTrex 20 is? Yes. You can go to Walmart, you can pick one up for about $200. That was the original spec. It was not spec'd by the GIS department. It was spec'd by somebody within Peoples. And when we asked him, why was this specification? He said, well, this picks up the Soviet system. So what about Trimble? He says, well, our Trimble doesn't pick up that system. Well, they had about a 10-year-old Trimble unit. Our systems do. So we actually rewrote the RFP to include a Trimble GOXH, tornado antenna, and basically modern data gathering. And that drove us to actually go talk to Alex and his staff, because now what happened is we're realizing that the people requesting it really have no idea what they want in terms of data. They know what they want to achieve. I think the question was that Matt asked is, what's your project? What do you want to get out of it? And they had a specific narrow band of information, but Alex and his department processes a tremendous amount of information, and they have a lot of other stakeholders besides the group that was requesting from us. So as a result, we combined with Peoples. We developed a data dictionary in coordination with their data outputs to the GIS department so that we were matching what they wanted to see. And then what we ended up with was the results that were clearly defined in an expanded set of data acquisition parameters. And this resulted in a much more comprehensive and efficient survey of the pipeline system. So I'll let Alex kind of talk about what the next portion of this.
So we have, Paul's had 3 or 4 field crews operating every day. Each user had a GPS unit. So we had approximately 12 to 16 users in the field with data collection. As you can imagine, that's an incredible amount of data coming back to one person. So we determined with our network security issues that maybe a Dropbox account was our best way to communicate data back and forth with each other. So every third day the data was delivered. I built a couple Python scripts to, once I downloaded the data, to get it back into like a file geo database, check the data, make sure everything was there. Any issues we communicated, there might be like a file that went rogue.
A few of those.
Yeah, so it's good. GIS was on top of this from day one. Otherwise, we received the data 130 days later, and we could have bad data from day 2. So once the data was in the file geo database, it was verified for accuracy. I pushed it to our SD, database entry. And from there, our field crews could see exactly where they were in the process of GPSing these lines. So how many leaks were found that day, how many exposed pipe, where they're having issues. I think that's just about it. And then it also went to like a flex viewer that the supervisors, managers of the departments, they could also take a look at it to see where exactly they were in the progress of the project, because every week there's a safety call, and we got to let the business know like how far we are along the project.
So from our standpoint, as we said, we had crews in there. Each crew, there was a 3-person, 3-technician crew. We had a utility designator. Their purpose was to mark out and follow the pathway of the pipeline. Now, this pipeline had a lot of continuity issues. Whole sections were Swiss cheese with a lot of leaks. So following directly behind that technician was a leak surveyor. And then behind them was our field mapping technician. So we had a technician with a Trimble GeoXH. Unique about this was we had long conversations with the GIS department on what they wanted to know. So it wasn't just, here's the pipeline. We actually located the pipeline. We located every appurtenance attached to that pipeline. So every valve we found, any weird piece of pipe that stuck up in the middle of the woods, every meter. Not only that, we photographed with the Trimble every appurtenance we found. So there is a geo-reference photograph of the condition of it, so somebody sitting in an office can look at it and not have to hike through the woods with a machete a mile to find it, which is important. The other thing that was important, that these systems were put in between 1898 and up to the 70s. These were hand-dug, many of them. Some areas they couldn't dig, so the pipe laid across the ground. So not only did we record the location of the pipe, but whether it was exposed, where the start and end point of the exposure was, where all roadway crossings were, where we needed to install new marker posts. So there was a lot of data that's in there that allows them a great deal of data mining at later dates. The equipment we used, a radio detection RV7000, the leak survey, we used a Sensit Tracker 3, and again, the Trimble is a GeoXH with a Tornado external antenna, and with the tree canopy, that external antenna was very, very handy. On average, I think we were, 95%, 50 centimeters or less throughout basically heavily wooded areas, which we think is very good accuracy level considering site condition. The terrain was very steep hills, good uncleared right-of-ways, farmlands, fields, couple of our guys got chased by livestock, which was kind of funny. And the records that we had, that Peoples had available from the previous owner, were anywhere from a few feet off to hundreds of yards. We were looking for one well, and it was the other side of the ravine. And just to give you an idea of what we ran into, this is our field crew. So you see the nice cleared utility easement we have there. What you don't see is about another 50 yards up the way, there's about 6-foot-tall brambles that they had to use machetes. They're wearing snake guards, not because of the snakes, but because the brush was tearing their legs up. And this was in the middle of July, wearing heavy-duty snake guards. It was a very tough project for everybody involved. You've all seen these nice cleared right-of-ways. That wasn't us. We're 50 yards to the left. That's the two white objects you see down there are the trucks. That's my technician wistfully looking that, gee, wouldn't it be nice if we could walk down that nice clear grassway instead of hacking our way through the woods. That's actually me trying not to fall into the creek because directly under that tree is our pipeline. A couple more pictures. The top one is our surveyor. Again, that is actually the utility easement. And this is what happens when you have an easement that hasn't been cleared in about 15, 20 years. So the only way you can really tell it's the easement is the trees are shorter. The middle picture there, that dirt spot, that's not dirt, that's actually what you'll find on leaks. If you're walking in the woods and you see a dead patch of vegetation and you know there's a pipeline nearby, it's probably a gas leak. There were sections that we couldn't get a good tone on the pipeline, but fortunately we could follow the dead spots through the field, and that allowed us to line up. And I'm not joking about that. There was one section, that's how we took our shots. We lined up the dead vegetation, and that gave us a straight line shot of the pipeline. The bottom picture, it looks like a tree trunk laying in the water. That's actually a pipe that was put in around 1920, and it's been sitting like that for that whole time. So this, again, is some of the challenges that you have within an industry that for many years has been somewhat neglected. These are low pressure systems, by the way. They're running 60 PSI or less. Most of them are 30 PSI or less. So there's not as big a risk, but you still have the potential for a lot of leakage over time. And when you're talking about trying to reduce methane emissions, it's an important factor to consider.
So the initial investment of this project was we needed to know where our leaks were on the gathering system. Since then, this project, the data we've collected has been invaluable. And the whole reason behind this is because the GS got involved day one of the project. We didn't just let the data come in and then deal with it how it came in. We determined exactly what we wanted at the start of the project. So how are we using the data today? Well, once the data came back, we needed to conflate from what we had to what we just GPS. So we had two GS techs working exclusively on matching the pipe to the points. Once that we conflated the data, we configured a 3-year leak survey plan. We have right-of-way and mowing cutting plans. There's plenty of right-of-way mowing that we need to get to, as you can see from the pictures. The planning department, we have built completely new models with the data that they collected from the wells. We know exactly where our gas coming in is and exactly where it's coming out with the meter data that they collected. And there's a ton of pipe that's exposed, plastic pipe that's exposed for who knows how long, so we need to get on top of that immediately to bury it. And how much pipe is leaking, our most leaks, or heaviest leaks, we need to get to those as quickly as we could.
Our final thoughts on this, we love this conference, by the way. We think it's a great place to share information. But one of the things that we want to emphasize, if you don't take anything else away from our presentation today, is that GIS is only as good as your ability to communicate it within your company or organizations or other people that are going to be signing the checks. And that's really what it comes down to. As we said, the original spec for our project was an E-Trex 20. That's because the person specing it didn't know everything that GIS had, the hardware, the software available, the capabilities. And really, as GIS specialists, as people that own and manage this, you really have an obligation within your organizations to embed yourself to really take, and not just stay in front of the screens and process the data, but when you're getting dumped on data and people say, how many have had people say, here's the data, can you do something with it? How many people have had that? So everybody here has had that fun rule. You need to get ahead of that. So what we did, we didn't have any new software. There was nothing, the software we listed, the hardware we listed, there was nothing in there that is not currently commercially available you can pick up off the shelf. The primary difference on this project was we changed the order of the GIS involved. Instead of the GIS being at the end of the project, here's the data, what do you do with it? GIS drove the project. And a lot of times what you have to realize is those people that are in there and giving you this project and saying, here, we want you to process this data, they don't realize all the stakeholders that the GIS departments are beholden to within a corporation. Your job is to say, hey, they have this project in this department, it may have applications in other departments. Can we maybe modify our presentation? We think this will save P&G considerable expense in the future, and the primary reason was all stakeholders were consulted that the GIS department had relevance to. We gathered all the data assuming a single pass theory. I mean, get it once right the first time. How many of you've gotten data and gone, geez, I wish they had gone back or they'd done this? We tried to do that all in a single pass. So now, with the effort that we had to go through the woods, I mean, it was hard work. We were hacking with machetes. We grossly overestimated how fast we could move. The three-man crew could do, on average, 2 miles a day. A normal human being can walk 3 miles in an hour. It took us 2 miles a day, and it took everything they had. They were exhausted every night. So you don't want to do that more than once. So we did it single pass. The data delivery was configured in a format that was minimized to minimize the effort on behalf of the GIS department. How many of you spent time trying to fix bad data? All right, everybody in here. So we tried to structure it in such a way that this was all minimized for them. And finally, the mini project, have a post-game summary. Get together, find out what worked and didn't work. There's other projects that they're working on now that have applications that what they learned from this will now be applied to that. So communicate that throughout your organizations. What did you learn from previous projects that may apply to a new project? And that's all we have. We appreciate everybody's time, and thank you.
We've got time for a couple questions, so.
You said you completed your data, so did you find any, or did you see any need to keep your old records at all?
We kept the same records, just
Right, but you didn't keep like a copy of what you had?
oh, we always keep copies of everything.
Okay,
Don't need it.
right, okay.
Anybody else?
If I can just, leave with one final conclusion, we are able to retire 77,000 feet of pipe from this system just from all this data collected. So where we thought we might have had a well was actually maybe closer to the pipe than we thought. So if the whole pipe's here and we thought the well was at the end, but it actually turns out that the well is here, and it's just pipe running out from the middle of nowhere, we were able to retire those segments all along the system. So the cost savings is astronomical.
Anybody else? Thank you very much.